Hello, I'm Jiten from AppsWise School. In this tutorial, we are going to create an API platform where simply by modifying one schema file, you can create any number of REST APIs. What's more, even in future, if you would like to create APIs for a variety of business objects, you will never need to tamper with any other files, be it routes, controllers, or models. Sounds exciting, isn't it? It is indeed. And to make it even more interesting, we are going to accomplish all of this using latest technologies and tools like Deno's and Mongoose ORM. Deno is a straightforward, contemporary, and secure runtime for JavaScript and TypeScript, employing V8 and constructed in Rust. Throughout this course, you will often see me copying code snippets from prepared scripts to help us save time by avoiding manual typing and the typing sounds. Feel free to adjust the video pace to your preference and enjoy your learning experience. This course is going to be brilliant because we'll be delving into some truly advanced concepts with exciting new technologies. Here's what we'll cover: comprehensive API development with Deno, advanced concepts of Mongoose ORM, including methods and statics, getters and setters, model validations, and error handling, login encompassing password hashing and JWT token generation. And finally, we'll deploy the application using Deno's Deploy with a free account. Shall we start with API development? Before we begin, ensure you have necessary Deno setup. If you are unfamiliar with Deno's setup, consider looking at our previous Deno's introduction course. I'll attach a card here and include a link in the description for your convenience. In this section, we'll delve into Deno's initialization and project structure setup, setting up routes for HTTP requests, wiring the controller methods for routes, and finally, we will define the schema and models to serve APIs. We will adopt a straightforward yet meaningful structure for this project. In addition to the files generated by Deno init, we will include a routes folder, a controllers folder, and a models folder. We will also have file named as deps.ts for managing the dependencies or the libraries. This is akin to package.json in Node.js for package management. This project structure is designed for convenience rather than strict adherence, allowing you to select the folder structure that suits you best. This is how our project structure will look, with the folders and files as discussed. Unlike Node.js, Deno lacks a package.json file for managing dependencies, and there is no need for a node models folder. Instead, we can directly access libraries using their URLs. Let's get started by initializing our server applications. To achieve this, we will require a third-party library known as Oak. Oak is similar to Express.js middleware in Deno. In our dependencies file, we will export both server instance from the Deno's standard library and the application instance from the Oak library. This allows us to import them into main file. Exporting libraries from dependency file assists us in centralizing dependency management across the entire application and simplifies version control. Now that we have exported the required dependencies from our dependency file, I am going to create a routes file inside our routes folder, and I am going to name it as index.ps. I am going to import the router from our dependencies file and initialize its instance. Now that our router is initialized, I am going to create a route for the get method. In this get route, we are defining a path along with path params. We are going to capture object name and ID using these parameters. The path parameters are available at context label in params attribute as a simple JS object. This way, we are creating highly versatile get route which can serve any object defined in our Mongoose schema and exported as model. And the next parameter for route is callback function, which accepts a context and provides context about current request and response to middleware functions. And as response body, we are returning a simple hello Deno message. Delete method will work exactly the same and will accept the same parameters too. And for now, we are going to return the same message as response body till we get into actual logic of these methods in controller files. Our post and put methods would also function in very similar way, except that the post method wouldn't require an ID parameter to create an object. Alright, we have set up routes for most operations, although there are few additional scenarios we need to address, like reading all, updating all, and deleting all objects. Let's establish routes for those two. Because these methods function as middlewares, and middlewares run in order they are declared, it's crucial to put the generic routes at the end and the specific routes at the beginning. And that's exactly we have done here. The specific routes are at the beginning and the generic routes at the end. And since we have declared all our routes here, let's finally export our router. I am going to remove the contents of main file. Let's connect the established routes to the main file so that we can test them before we dive into creating controllers. I have imported application instance from our dependencies file, initialized it, and defined a port before we start listening on it. And I have also imported the routes into the main file and have used it into the application instance. Next line tells Deno to allow methods for these routes like get, post, put, and delete. I have added an event listener which takes two parameters, event name being the first one and a callback as the second parameter. Callback itself take an object with boolean flag secure, a host name and the port. By checking if we are in a secure environment, we use either of HTTPS or HTTP protocol, and we construct the URL by using the received hostname and port. We log a message to confirm if the server is running, and finally we start the server by listening on defined port. We have been coding for a while now. It's time to perform a quick test to verify that what we have accomplished so far is correct and functioning as intended. We'll be doing so by using a REST client, Postman, but before that, let's start the server by using the command deno run -a main.txt. Now that our server is started, we can go ahead for the testing. Let's open the Postman REST client and we can start with the get. Let's do a quick get request, localhost and port 8000. As an object, we will select user for now and we will give it an ID of 23. Let's hit the send and check the result. And this is successful. We got the response as hello Deno. We can test the rest of the routes in similar way. Change it to the post, and since post doesn't take any parameter for ID, we can remove the ID and hit send, and this is success. Let's change it to the put route, and since update method takes an ID, we are going to provide an ID and click send, and this is success as well. And finally, let's do the delete. This is also success as desired. Let's remove the ID parameter and check the generic route. Now this will act as delete all, which is success. This will do as update all. This is success as well. And finally, we'll do a get all. This is successful as well. And this confirmed that our routes and main file are wired correctly and functions as desired. Next, we are going to create methods in controller files. These methods will contain the required validation and wiring logic of routes to Mongoose model. I'll create an index file within the controllers folder to start populating the methods. Let's commence with create method. We'll retrieve the user object from the request body and the object name from the context path parameters. Then we will invoke the model's create method and store the result in a result variable, which then we will return into the response body. We have encapsulated the whole process within a try-catch block, and we are returning the error message as response body if we encounter any error. Let's now proceed with the get method and the get all method. The only distinction is that in the get all method, we don't need the object ID. And there is no need for any input from the request body in any of these methods because we are retrieving the desired object from the database. Next, we will proceed with update, update all, delete, and delete all method. Similar to get all method, we don't need object ID in update all or delete all method. For update and update all method, we will be taking objects attributes to be updated from the request body. And finally, we will export all the methods so that it can be wired back to the roots. Before we start working on Mongoose schema file to define models, we should include some more libraries into dependencies file. First, we will import Mongoose model and schema from Mongoose library. This will help us defining Mongoose schema and export it as model. Second, we will import another library called Mongoose increment that will help us with auto incrementing object ID. As a next step, I am going to create a schema file where we will define the schema and export the model. Now I'm going to import all required dependencies from the dependencies file and initialize Mongoose increment plugin. And then I'm going to create a person schema with few basic attributes such as name, date of birth, gender, phone, and email, where date of birth being date, gender being an enum, and email being unique string properties. The rest of the attributes are going to be string with no validation whatsoever. I'm also enabling the timestamps option as true so that we have created it and updated it attributes without defining it explicitly for auditing purpose. Finally, I'm going to enable the auto increment option for the person schema with unique ID field named as ID and getting incremented one at a time. And the last thing is to export the model object as default from the schema file. Now that the basic person schema is ready and the model is exported, I'll create a model.ts file inside the models folder to wire the controllers method to the Mongoose model. I will then import the schema file and the Mongoose dependency into the model file. Once done, we'll connect the Mongoose ORM with the database by passing connection string to Mongoose instance connect method. And then I'll create a create method to link the controllers create method with Mongoose ORM create method, which will be an async method and will take two parameters. First, the object name and the object to be created. It will then invoke the Mongoose model create method with the supplied input object of the desired object name. In our case, it's the person model. Next, we would create find one method which will serve the get request for finding one record. This method will take an object name and the filtered criteria. And let's also rename the create method's parameter name to avoid the confusion at later point of time. In a similar fashion, let's also create the find all, remove and remove all method. Find all and remove all method will not take a filter criteria because it will act on all available documents in the collection. Finally, we will finish it by creating update and update all methods, where both will take an input object to update. An update all method will not have filter criteria. We will export all these methods at the end and that will conclude our models file. One last thing we need to do is wire the controller method into the root file. For that, let's import the controller into the root file and start changing our dummy callback with the controllers method. For the get method, we are going to replace it with controller.get. For the delete, we are going to replace it with controller.remove. For post method, we are going to replace it with controller.create. And for the update method, we are going to replace it with the controller.update. For the generic routes, for the get method, we are going to replace it with getAll. For the update all method, we are going to replace it with update all. And finally, for the delete method, we are going to replace it with the remove all method. And with that, all the basic CRUD APIs are ready now and we can start testing these using the REST client Postman. We can now start testing the complete CRUD APIs. For the person model, let's start the server and open the Postman to commence. Now that server is started, let's go to the Postman to start testing the APIs. And first we will create the person. And this is the payload as per defined schema. Let's hit the server and our first person is created. Now let's create some more persons to test our generic APIs. This is the second person, created successfully. This is the third person, created successfully. This is the fourth person, created successfully. And this is the fifth person, and it has got created successfully too. Since we have created enough records using the post API call, we can now test the get and get all API. I'm going to test the get all API first and take the ID to fetch a specific document using the get API. Now this is the get all API and I'm removing the payload and click send. And as a result, we can see all the records which we have created. Let's take ID 15 and we will use this to test get API. As you can see, the get API is working fine and we are able to fetch the particular document by a specified ID. While we are at it, let's also test the delete API for the document with ID 15. I'll change the method to delete and send the request to server. And you can see this particular document is deleted. And we can confirm this by changing the method to get and try to fetch it. Since this is removed, we are not able to fetch it. That confirms the delete API also works fine. We can also test the update and update all methods. Let's test the update method by first updating Rahul's name to Rahul B. And for that, I will change the method to put and supplying the name payload in the request body. And as you can see, we got the success response. We can confirm if the document has been updated by invoking the get method and checking the name in the response. Let's change the method to get and invoke the server again. As you can see, name has been successfully updated. To test update all API, let's assume every person on our database belongs to the same team of developers, and hence their phone number has to be updated. For that, let's supply the input payload as the phone in the request body and change the method to put and remove the ID from the path parameter to indicate this is the update all method, and then invoke the server. As you can see, we got a success response, and let's check if the number has been successfully updated for all the records. Let's change the method to get and invoke the server again, and you can see all our documents have the same phone number. That confirms the update all API works perfectly. Finally, to test delete all, let's assume the company they all work for went bankrupt and they removed all the developers using delete all API. This is ironically simpler than onboarding the employees for some reason. Let's change the method to delete and invoke the server. As you can see, we got the success response with the deleted count 6. Let's confirm this by changing the method to get and invoking the server again. Since we did not get any response, this means our delete all API works fine. We have a complete working project structure now. Let's look into a bit more advanced Mongoose concept called discriminators. Discriminators are a schema inheritance mechanism. They enable you to have multiple models with overlapping schemas on top of the same underlying MongoDB collection. We can achieve this using the model.discriminator method. This method takes three parameters: a model name, a discriminator schema, and an optional key which defaults to the model name. It returns a model where schema is union of the base schema and the discriminator schema. To demonstrate this, let's create another schema admin, which will have three additional fields from any other users or person: a role, a password, and a department field to show the department the administrators belong to. Also, let's create an object for common options to supply to the base schema, which in our case is person schema, and supply this option object to the person schema. Now that the person and admin schema are ready, let's create a model using Mongoose. It will return a model whose schema is the union of base schema and the discriminator schema. And with this, we are ready to test our admin API, which should create some admins in the same collection as normal user. To test this, let's create an admin first with the admin payload on the request body, with additional parameter as role, password, and department. We are assuming in this solution only admins will be able to log in the system to manage the normal user. Let's invoke the server. With the success response, let's check the database under which collection the admin user got created. It was created under the user collection. Now let's create a normal user with the person API and without the admin fields. Let's invoke the server. With the success response, let's check the database under which collection the normal user got created. So it was created under the user collection, which confirms that the discriminator mechanism is working as intended, and we don't need to create different collections for different user roles. As you may have noticed that we are storing password for admin in plain simple string, which is not at all good practice, and there is no security whatsoever with this. Let's ensure that the passwords are properly hashed and stored securely in the database. For this, let's export the hashing library bcrypt from the denoland and import it into the schema file. Here we are going to use another advanced feature of Mongoose ORM, getters and setters. Let's create a setter for password attribute in the admin schema, which will hash the password before storing into the database. One thing to note here is we are using the hash sync method of bcrypt here to avoid resolving a promise inside the setter method, which is okay in this case because payload for this object isn't big and can be processed quickly and asynchronously. However, for bigger payload, it is always better to use async method. Getter methods work in very similar way, but it's more of a synthetic sugar for presentation, which means it only returns the data in desired format without actually manipulating the actual object in the database. Let's decorate the department field while returning back the result to make more human sense by introducing a getter method. As a final step, let's also pass two parameters to enable the getter and setter methods for the admin schema. Now we are ready to test this. Let's create an admin and check if the password attributes get hashed, and we also get the human readable department field. And as a result, the password field has been hashed successfully and department field is in more human readable format. We will also need to let the admin login using his email and password. For this, we would need Mongoose instance static feature. Mongoose schema can allocate a static method to be called on the schema without creating an instance of the model. This model is basically a callback method and can accept some parameter. We first need to import another library to create a JWT token, which is called djwt, and we import it from denoland and export from the dependencies file to be further used in the schema file. Let's import it in the schema file. And now let's define the callback for login. Let's understand what's going on here. We are finding the admin with provided email ID to check if any such admin actually exists. If it does, we proceed. Else we return nothing and exit. We have already seen decrypt in action earlier while encoding the password for admin. And now we are using compare function of decrypt to compare the encoded password with the supplied password, which only returns true if both the password match. If it does, we know we have a genuine user and we need to return him the JWT authentication token for his future API call, and hence we generate a JWT token with the create method of third-party Deno library djwt, which we have already imported as dependency from the dependency file. The create method takes header, a payload, and a crypto key. We use the native web crypto API to generate secure crypto key, which takes an algorithm, an object defining the type of key to generate and providing extra algorithm specific parameters. Extractable, a boolean value indicating whether it will be possible to export the key. Key usage as an array indicating what can be done with the newly generated key. We supply the user object as payload to create the token, and header with the algorithm we want to use to encode the token and type of algorithm we want the token to be encoded of. Finally, we return the generated token as the final result of login operation. Now let's assign this callback method to admin schema as statics, so that we can call this on the schema instance without initialization. The difference between statics and method is we can directly invoke instance statics without initializing the instance first. And for the instance method, we need to initialize the object before invoking the methods. After this, I'll create a login method in the model file to link the controller's login method with the admin's static login. Let's export this login method from the models file, and also create a login method on the controller file to wire the router's login API to the model's login method to invoke schema's static login. In this login method, we are accepting the object name from the context param and headers from the request headers. We are passing the email and password on the request header, which we are supplying forward to the model's login method for the static method to process it. Now let's export this login method from the controller file as well. And finally, let's plug this login method into our router's login route. And with this, we are ready to test our login API. In the Postman REST client, let's invoke the login static on admin object by passing the admin's email and password through request headers. Let's invoke the server and we should be receiving the JWT token as response. And as a result, we have received the JWT token as response, which confirms our login API is working fine. Mongoose validation is simply a programmable middleware that is defined within Mongoose schema's schema type. It is triggered automatically before a document is saved in the NoSQL DB. Validations can also be performed manually by calling the doc.validate method or doc.validateSync methods. Let us learn more about this by using a few cases. Before we go into mechanics of validation syntax, let's go over some ground principles first. The schema type defines validation. Validation is a type of middleware. By default, Mongoose registers validation as a pre-save hook on every schema. Validation is always the first pre-save hook. This means that any changes made in pre-save hooks are not validated. Undefined values are not passed through validators. The required validator is the lone exception. Mongoose does sub-document validation when you call model save. If there is a mistake, model save promise rejects. Validation can be altered. Mongoose have many validators. The required validator is incorporated in all schema types. The check required method of the schema type is used by the required validator to see if the value meets the requirement. There are min and max validators for numbers. Strings have validators such as enum, match, minimum length, and maximum length. If the built-in validators are not enough, you can always define custom validators to suit your need. Custom validation is declared by passing a validation functions. There are two types of custom validators: synchronous custom validators and asynchronous custom validators, which means custom validators can also be asynchronous. If your validator function returns a promise, like an async function, Mongoose will wait for the promise to settle. If the return promise rejects or fulfills with the value false, Mongoose will consider that as a validation error. Now let's look at some examples of validations in our use case. We have already seen required validator for the phone number in the person schema. Let's define a custom validator for phone number for person schema. Since we should not really declare phone number as number, and also string validation can't be applied because we wouldn't want characters to appear inside the phone number. It's a good use case for custom validator. As discussed earlier, the validators can be asynchronous, and we are using an asynchronous validator here, which takes phone number which needs to be validated. We are simply checking the length and using a regex to validate this phone number. We are returning valid, which is going to be true in case it passes the checks, and false if it falls under any error or the validation doesn't go through. Now let's use this phone validator inside our person schema for the phone. We will still be declaring the type of phone number as a string and a validator, which will take the validator itself as the first param and a custom message or error message as the second parameter. While we are at it, let's also understand the error handling within the schema itself. For every validation, we can pass a custom error message, which makes more sense because the generic messages are not always human readable form. For the example, if we want to pass a custom error message for this required validator, the syntax would remain same. We would put an array as the value of required validator as the first parameter and a custom error message as the second parameter, where we can simply say email is required, and that becomes our custom error message. And this is how we can handle the errors inside the schema. And finally, let's test this using the Postman REST client. Let's first remove the email to check the email validation. As you can see, we got the error message stating that email is required. This is the custom message we pass to the required validator. This is the custom message we pass to the required validator, and also it gives us the message which is for the phone number validator. And this is exactly as we declared it. Phone, the given value of the phone, is not a valid phone number, and this confirms our validators and error handling is working fine. Deno Deploy is globally distributed platform for serverless JavaScript and TypeScript applications. The simplest way to deploy complex projects is via GitHub integrations. This allows us to link a Deno Deploy project to a GitHub repository. Every time we push to the repository, our changes will be automatically deployed. Before we start deploying application on Deno Deploy, there are few steps we need to perform. First, we are going to use Deno environment function to use the environment variable. We are going to use db URL environment variable to store the database URL. And let's remove this manual connect method, and we are good from our model file. Second, we are going to change the server port to 80 because that is the default port for the HTTP requests in the server environment, unless there are any load balancers we manually used. Since Deno Deploy is a managed instance, we don't need to do any manual changes, and simply changing the port to 80 will do for our application. I have moved the code repository to GitHub, and let's go to Deno Deploy and start deploying our application. As the first step, we will create a new project in the Deno Deploy and select the user account. Next, we will select the repository we want to deploy, and we will keep the main branch as default. Since we don't need the build steps here, I will click on no build step and will proceed. Next, let's click on create and deploy, and Deno will start processing to deployment. Once that is done, our project is here. Now when the repository is connected and project is created, let us also provide the environment variable db_url to our application. From the settings menu, in the settings menu, we have environment variables here. We'll click on add the environment variable and provide the environment variable as db_url. I have masked my db_url. You can provide your database URL here and click on save. Once saved, your environment variable will be available for the application to use. Now that our application is deployed and successfully running, let's test it. You can see all the recent deployment here. To test the application, we are going to take the application URL and we are going to move to the REST client Postman. In Postman, we can change the request URL's hostname and port as per our Deno Deploy application and invoke the server. We got a successful response, which means the person is created, and this is how we use the Deno Deploy. I hope you enjoyed the lectures covered in this tutorial. This will keep us motivated to bring more quality contents on technology and development related topics. We are going to cover more advanced topics such as Deno's built-in tooling like Deno Formatter, Deno Linter, Deno Test Runner in upcoming tutorials. To get the notification, click the bell icon and stay tuned. Feel free to comment and let us know what specific aspects of Deno Runtime you would like to learn next. Your inputs are valuable to us.